Okay, we'll summarize these topics also now. Overloading and overriding. See this. One side you have got overloading, other side you have got overriding. Both are polymorphism only. Polymorphism means what? One name, many forms. Name will be same, but you'll have different forms. So overloading means here, why do you do overloading? When the functionality is similar. Why do you do overriding? When you want to add or change functionality. So huge difference is there between overloading and overriding. So we do it when functionality is similar. Huge difference is there. Remember that. Miller. And we do this for adding or to add or change functionality of existing methods. Existing method means you override always in subclass. Okay, so this is overloading, and the criteria for overloading is number, order, and data type of the parameter. And criteria for overriding is what? Object, type of object. This criteria is very important. Type of object means which object you create. The overridden method from there gets access. So methods are always searched from the bottom. Okay. And here in overriding, okay, how do you overload? How do you overload? By either means name of the method will be same. Name of the method will be same, but there will be change in parameters. One second. A number, order, and data type criteria. Here a return type doesn't play a role. Yes or no? Doesn't play a role. Okay. And see, to make a good example for this, overloading now. Void M1. Okay, in class A, void M1 int A. What is this? Overloading. This itself is called as overloading. Overloading can be done in same class, plus it can be done in subclass. Overloading means name is same, but change in parameters. Either the parameter can vary in number, order, or data type. Okay, this is overloading. Second. Yeah, 1 second. I'll clear this now. Yeah, so this is called as overloading now. Now class B extends A. What is overriding? See, name is same again, void M1. What is this? Overriding. So overriding always in subclass. So what do you mean by overriding? Name. See, all this is polymorphism only now. One name, many forms. One name, many forms. Here name is same, here also name is same. So in which one? Overriding, what happens is, we generally say, okay, I'll override int A, better. So in overriding what happens? We are overriding M1 of int A. So this one we are overriding. So in overriding what happens? The signature of the method should be same. Signature of the method means actually this part. Actually long back I think I told, return type, name and parameters all make signature. I think I apologize for that. These only the parameter part is called as signature. Only the parameter part means the parameter part is called as signature. So signature of the method means only the parameter list. Understood? So that's, I think long back I told, all the three things put together make what? Signature. But now I'm telling clearly, return type, name do not form the signature. The parameter list forms the signature. So in overriding, the signature should be same. The methods name, in overriding what you should do if you want to do overriding, the method name, the signature and return type, all the three should be same. Understood? In overriding, if you want to do overriding, what you should do? Three things should be same. Means you should take care of three things. Return type. Okay, first thing. Then this is what is overriding. If you want to override, what will you do? Three things. To override, you have to check three things. One is return type. Second one is name. Third one is signature of the method. That is when we say method is overridden. Means name, parameter, type of means signature of the method means number, order, and data type of parameter. All these three things put together make the signature. Yeah, that's what is overriding. So that's it, I think. If you want, you can again overload where? In subclass void m1 int a int b. What is this? Overloading. Like this it goes on. But you should know, simply you don't go on overloading and overriding. No? You should know when to overload, when not to overload, and when to override, when not to override. Understood now? This is overloading. Clear this? Okay. So I'm just finalizing all these things now. What we are summarizing all the things. Shall I clear all this? Okay. Now what all you can overload, that also we'll see. See, in overloading, what all you can overload means, you can overload only two things. First one is constructors, second one is methods. You can overload both of them. Okay, methods, you can overload even static methods also, you can overload even instance methods also. So overloading is possible for constructor also, method also. Clear? Both methods, static and instance. Okay, now overriding. Generally we have many things here. Variables, constructors, third one is methods. Okay. So variables cannot override. So if you want to understand this concept, you try with the dynamic polymorphism. Then only you'll understand. Understood? Variable overriding. How will you check? With the formula of what? Class A int x is equal to 10. Class B Class B extends A. Int x is equal to 20. Now, only if you want, so this is class demo, it will continue now. Okay, PSVM. See, AA is equal to new A, it will work with x of A. A dot x, it will work with x of A. BB is equal to new B, it will work with which one? X of B. B dot x. See, the difference is, in A object there is only one x. In B object there are two x. One from class A, one from class B. Because it's inheriting. So this will print 10. This will print 20 if you print. Print, this is how it prints. So here you will not understand. Actually you will understand where? When you do dynamic polymorphism. You say here, what you will say? A is equal to new B, you say. So earlier what was happening? This was A object referred by A, B object referred by B. But B dot x means it was accessing from subclass. But now if you say A is equal to new B and print A dot x, it will print you 10 only. In this scenario what's happening? This is a different scenario. In that scenario what's happening now? There are two x. X is 10, B is 20. And who is referring to this? A. Why? Superclass variable can refer to subclass object. It can refer. But A dot x it will print 10. This shows variables cannot be overridden. Clear? So you cannot override. This is wrong. Constructor cannot override. Why you can't override? Many reasons. Class name and method name should be same. Or other one is constructors are not inherited. Okay, many reasons are there. So you cannot override constructor. Methods you can override, that too selected now. Which one? You got static and you got instance. So only methods you can override. Okay? Now static methods again you cannot override. So what all you cannot override you should understand now. Cannot override. Instance you can override, but only which one? This is wrong. Understood? Static you can't. Instance you can, provided there is a condition. Which one? Private, static, final. These you can't override. Okay, you can't override private, static and final methods. Sorry, private, final. Instance methods will be private and final. Correct? Na? Static I already written, so you can override only this. Clear? That's it. So your Java supports only method overriding. That's it. So you should know what to overload, what to override. A brief summary of this. Why do you do all this, you know? And remember, always keep in mind, criteria for overriding is object. That one thing you should always keep in mind. I just summarized everything here. Any day you are having doubt about this, start using dynamic polymorphism. Anything which and only thing which supports dynamic polymorphism is what? Instance methods. The only thing which supports dynamic polymorphism is instance method. So what supports dynamic polymorphism is only called as overriding. That's another way of looking at it. Yeah? What supports dynamic polymorphism only is called as overriding. Clear this? Still more examples are pending. But just I made a summary of all this now. Clear this? Shall we clear all this now? Okay, so these are the things which you can overload. Overloading clear now? Only two things you can overload. Any questions here? Any questions? Okay, if you are having doubts also, they will be cleared. They will be cleared because still more examples are there and your doubts will be clarified in the, because in one example I will be covering one concept. Now for one concept I need another, one example. Another concept, another example. So now I am teaching you that concept, definitely you will get the doubt for another thing. To clarify that only we will be having another example. Like that it goes on building now. And these are definitely interview questions to you all. Clear? Shall I clear all this now? Functionality is similar, add or change functionality. Okay, we have seen this now. Okay, one more very good example we'll see now for overriding. Very interesting example. Okay, very good example, but just see this. Remember, always remember, criteria for overriding is object. That one thing you do not forget. Criteria for overriding is object. Definite interview question as well as SCJP. SCJP or this one, this will be asked, guaranteed. Why? You will only understand, see this. See, before you always go to overriding, work with one class correctly. Then you'll get the grip on subclass. Understood? See this. There's a class called as A, and there's a class called and there are two methods, M1 and M_fun. There are two methods. Okay. Let's try to use these methods here now. Class demo. So once you have got the class and its members, generally what you do, you create an object and you work with the members. Generally that's what happens. So see this, I created the object and I can work with the members. So when you created A object, what is happening now? A object gets created. It is having M1 method and fun method. These two methods are there. This is A object, address is 150. Any questions here? No? Okay. Now see, the members of class A, I am accessing in class demo. Means a different class, unrelated class. How do you access? Create the object and you start accessing it with dot operator. Valid, no? Okay. Now, sometimes we have already seen this. Sometimes what happens? The method present in one class can be used outside the class also. The method present in one class can be used inside the class also. See this? I can call fun in M1 now. Valid now. So I can call means I can access the member inside the class also. Means fun member is getting access to, concentrate on fun method now. Fun method is getting accessed inside the class also, fun method is getting accessed outside the class also. Both the places you can access. But in the same class directly I'll call, or I can use this dot fun. Option is there. But here I have to say variable dot. Are you clear with this? Do you have any questions? No? Yes. We'll start overriding. Then see what's the thing now. So if I say fun, definitely it will print. Now you call. I'll call fun method now. Okay. If I call fun method, see I'll call only a.m1 now. Now I'll not call a.fun. So you call a.m1. What will m1 do? It will only call fun. It will only invoke it. Clear with that now? So A object is clear. I'll move B object now. Check this. Class B is a subclass now. Definite interview question. If you are good in overriding, you'll get this point now. So I can have one extra method that is optional. It's optional. Now see this. Void fun. Second, I need space. Yeah. Now I'll just remove this. We'll come back to this program again. See what are the members of the class now? M1 is there. Return type is void. Understood? Then if fun is there in class A. Fun is there. Return type is void. Now next class B extends there. What's happening? M2 is there. Return type is void. Fun is there. Return type is void. But just go on doing seeing that. Always you should check. I'll be giving you clear notes for this. Before you work with your data types, you should check what they contain. Like there's one big detailed notes for this. I'll give you. Okay, that next I'll give you. So whenever you are anybody asks the output for you, follow this rule. First check how many classes are there. First you have to study like this. Before you get into main program, if anybody asks you the output and asks you the what is the output of a program, don't look into main. You'll not understand. Why you'll not understand main is because in main they'll be using what? User defined data types. So until and unless you don't know your user defined data types, you cannot predict the output that's it. So that's why always before looking into the program you should check what? How many classes are there? How many how many classes are there? Are they related or not? Are the two classes related or not? If they are related, how they are related? Whether they are related with is a relation or all this you have to check. Understood? So right now, based on that, I'll start telling you. After identifying the relationship, then you have to understand the members. You have to understand the members. What members? See, there's a method called as M1. You should see the parameter, no parameter. You should see the return type. Why you should see all that? Because when you're calling the methods there now, you should know which one will be called now or how to call. How to call also you should know now. Now to call M1, can I send a parameter there? No. So when you know the signature of your method, then only you can call the methods properly. So all this you have to check. Name, return type, parameter, how many methods are there. Then once you study that, then you have to come to subclass. Then again check M2 method is there. Return type void, no parent. So now you should think it's a new method. Now as soon as you see the same thing, see if you observe carefully here, then only you can come to know it has been overridden here. Otherwise it will be like class A, class B, over. Understood? So there are some notes I'll give you in the next class. Okay, like steps to identify class and members of the class. All this you have to study. Only then you can predict your output and make it mandatory rule. Whenever you look at that, whenever you are looking into the output, first see these things. Okay, so anyway, we'll come back to that now. So based on that, we have seen everything now. I'll tell you now what are there. There are two classes A and B. See now I'll tell you how to look into this program now. There are two classes, namely A and B. You should know the name of the class also. Then B is the subclass of A. In class A, there is a method called as M1. Return type is void, no parameters. There is one more method fun, no return type. Understood? And there are no parameters. Now in class B, M2 is there, no return type, no parameters. Fun is overridden method. That's what you have to understand. You don't have to tell now return type, name and all that. Fun is overridden. Immediately you should tell that. Understood? You should know when you understand your program now. Let's see the output now. B is equal to new B. See, till now you have studied all this. It's not a problem for you. Till now we have seen this, but see this program very carefully now. BB is equal to new B. You might be thinking, what is so great about this? See this, BB is equal to new B. Now which object is getting created? B, it is having two methods, M1, fun, M2 and fun. These are the methods of B object. So there are four methods, and you know very well, I taught you overriding very clearly all the methods. Now see, A class, B class, members. So when you create the B object, both will come into existence. So when you create the subclass object, superclass members and subclass are coming into existence. Now I am accessing B members in another class. Carefully see now, we are accessing what? Subclass members in another class. So how to access subclass members in another class? Same story. Earlier I showed you how to access class members in another class. Now we are seeing how to access subclass members in another class. So I created the object. Now I am accessing with what? Dot operator, b.m1, b.m2. You know how it works. Looks in the bottom class. If not found, it will execute from superclass. Understood? You know how this works? b.fun. You know how it works. Again, fun from subclass only is executed. Do you have any questions still here? No? This is clear. Now very interesting. What I'll do is, in M2, see, we access the members outside the class. Which one? Fun. Now the same fun method, I'll access it in subclass. Now let's see the output. Understanding now what I did? I access these members outside the class. Means B members I accessed where? In demo class, another class. They are not related. And now you saw the clear output, you know. But in B class now, in M2 method, I'll access fun. Which one will get executed? So now see this. This you know leave. This you know leave. Understood? B.M1. It will execute from, it looks in subclass. Doesn't find executes from superclass. B.M2. It finds in subclass, it will execute from subclass only. But M2 is calling one more method. Which method? Fun. Which fun gets executed now? Remember, the criteria is object. This is where you get confused. Okay. So it looks in the bottom itself. It looks in the bottom itself. Every time the method is invoked from the object, searches in the bottom first. That is one way to see it. Another way of it is, preference is given to local. But more than that, better I can say, criteria is object. Don't look into local and all. Criteria for overriding is object. You invoke it from anywhere. You invoke it from anywhere, outside the class, inside the class, wherever you invoke. Criteria for overriding is object. Do not forget this. Are you following now? Now you might ask, why should I invoke fun method in M2? It might be you want to use the logic there. You might want to use that logic there. Instead of writing it, you are invoking it. Understood now? Are you clear with this? Are you clear with this? Okay. Now, next. Very interesting. Now what I'll do is, here I called fun in B class. Now see this. Now B is a okay, again we'll come back to this now. This is the most important program now. Earlier you saw A is equal to new A.M1. Which one was executing? A is equal to new A. Now we are calling see, A is equal to new A. Just I'm calling fun in M1 also now. So let's see. A is equal to new A.M1. So A object is created. Fun has to execute. Which one will execute? Same class. Here no problem for us. BB is equal to new B. BB is equal to new B. B.M2 you understood. Understood. It was calling from subclass. B.M1. In M1 also we are calling what now? Fun. Valid. Which fun will execute? Subclass only. This is where we get the confusion. Most of the developers fail here only. They don't know where it is executing from. Methods are always dispatched from the bottom only. A is equal to new B. Sorry, what is that? BB is equal to new B. B.M1. M1 we are calling. M1 has to call fun now. It will not call this. Again it will call from subclass only. Criteria for overriding is object. Remember that. From wherever you call it, you call that method from superclass, subclass, another class. Wherever you want to call. Till now I was calling it from another class. Today I am showing you how to call it from subclass and superclass. Okay. So now see, when you compile, compiler compiles. Why it compiles? When you compile this now, M1 can access fun now. So it will compile. So what members can be accessed depends on what? No, what members can be accessed is decided at compilation time. So it will compile because class A knows everything about fun. It knows about fun. It will compile. But when you create B object, Which one gets accessed? Depends on the runtime. So what members can be accessed always depends on during compilation. It's decided at compilation time. Which member gets accessed is decided at runtime. Understood? But the same M1, if it tries to call M2, error when? Compilation time. So this is where people start getting confused. But you don't have to get confused. Criteria for overriding is object. It's very clear. Why the method from subclass is executed? I've told you 1,000 times, sir. The reason why you are creating subclass object is you wanted the logic from subclass to execute. If you wanted the logic from superclass to execute, you would have created the object of superclass. So do whatever you want. When you create the subclass object, preference is given to subclass only. There is no confusion here. If it had executed the method from superclass, then there would have been confusion. So they are making it very clear. If you create the subclass object, the methods are searched in subclass first. They are making it very, very, very clear. There is no confusion only. Always methods are searched from the bottom. Understood? Now if I create bb is equal to new b, and if I call b.m1, if it had executed this one, this would have been a mistake. Why? The reason why I created subclass object is I wanted subclass logic to execute. Yes or no? Now that is not happening. It is executing correctly from where? Subclass. If it was if M1 is invoking from superclass, it would have been confusion. But correctly it is executing. Check. Are you clear with this? More things. See, if I want, I can do like this also. A is equal to new b. You have to try with all permutation and combination. So now what's happening? Here only I'll adjust. A variable is referring to which object now? B object. A dot M1. Can I access? Yes. So what can be accessed is checked during compilation time. So it will execute M1. But M1 is calling fun. Which one? Subclass only it will call. I'll show you. Type and show you all this. Clear? Okay. A dot fun. Okay. It will call from subclass only. If you call fun directly, it's okay. Okay. But A dot M2 is error. Why? Superclass cannot access. This will continue now. What members can be accessed depends on type of variable. Which one gets accessed is decided at runtime. Only change is I am using superclass variable to subclass object. But the same thing, see here, do not get confused. If I say A is equal to, see A dot M1, here which one is M1 calling? Take this now, this case you take now, A is equal to new B, just I am using the same code. Okay, so if A is equal to new B, what happens? B object is created, A dot M1. M1 is invoking which one? Fun from subclass. Understood? But see the change here. A is equal to new A. Now which object is created? A object. A is equal to new A. See the same small change. A is equal to new B. Fun from subclass. A is equal to new B. A dot M1 fun from subclass. A is equal to new A. A dot M1 fun from same class. Criteria means it checks locally this time. Means locally means in the object. First preference is given to the type of object. Are you clear with this? So criteria for overriding is object. Understood? You can access that method from anywhere. Superclass, same class, outside the class. So I am accessing the overridden method here from where? Superclass. In fact, you might put a question now. Superclass doesn't know anything about subclass. Yes, but still it is calling from where? Subclass only. Why? Because superclass doesn't know anything about subclass. Fine. Compiler also will compile. Why it is compiling? Because you are calling a fun method which is local. So what members can be accessed is checked at compilation time. But during runtime it is speaking from subclass. Because criteria for overriding is always object. They stick on. They are not changing anything. You access it from anywhere. So can I access overridden method from superclass? Yes, 100% true. Understood? Can I access overridden method from subclass? Yes, 100% true. But you might ask me, why should I access the overridden method of subclass in superclass? Understood? Sometimes you'll be decoupling like this. You'll be telling, what you'll be telling? A is equal to new B. You'll be telling like this. Understood? And sometimes, okay, you will call method now, but you want the logic of subclass to execute. Yes or no? Your intention of creating subclass object is what? To execute the logic of subclass. Yes, that is when you call M1 also, fun will be executed from where now? Subclass only. Perfect it is. Sometimes this will happen. Understood? Not only this, you can go with this. Class C extends what? A. You can have M3. Extra method leave. Or you can have void fun. So you can print your SOP inside C fun. This is okay. But now see, loose coupling you see. A is equal to new C. Which object I created? C object. I want fun from which object to execute now? C. Perfect. A dot M1 you call. Now in C object what's happening? What are the members of C? M1 fun. M3 M1 fun. M3 fun. So which object you created? C. But in M1 you are calling fun. Which one gets executed? Subclass. Yes. You'll go on decoupling. Perfect it is. Remember, do not forget, once overridden method means from wherever you call. Criteria for overriding is object. Clear this? So this is one last place where developers find overriding confusing. Means it's correct only they get confused. Understood? It's correct only. What behavior Java is giving, they are not confusing developers. Only developers are getting confused. Understood? So just check this out. Okay, I'll also type and show it to you. Learn this properly. Okay, so this is how overriding works. Till now we are working with overriding outside the class. Now only difference is what I have done is I'm calling that method in subclass. Subclass also you understood, no problem. Only the doubt is now when I call that method from superclass, it is executing from in superclass. When I call that method in superclass, the method is getting executed from subclass. That's all. That's one thing now. Just work, you'll understand it. Clear now? I'll type it and show it to you. It will become more clearer to you. Clear?
Sir, actually I have a doubt. Sir, when we write this BB is equal to new B, two objects are created. One is B object and one is A object.
BB is equal to new means?
Actually two objects are created when we do that. We put
Two objects are not.
instance block and write that this one is created. So when I tried I got A object was created and B object was also created.
Both will not execute. Actually, okay. In fact, in the JVM what will be happening is, to tell you very clearly, when you create subclass objects, they are created independently, that's all. They are created independently like this.
But will there be a link between those?
Yeah, it will be a link. This question is, when I create BB is equal to new B, will A object and B object both be created? Okay. Both of it looks like when you put the static block, instance block and execute, it looks like A object is created separately, B object is created separately. But fact is, yes, it is the way they are created in JVM. A object is created separately, B object is created separately. This keyword will be referring like this. Super keyword will be referring. See how it happens. Super keyword will be referring to the superclass object like this. This is how it happens. Understood? I'll show you one more example for this. Okay. So this is how it happens. Okay. So that's why when you create the subclass object BB is equal to new B, you can see instance block and constructor of A also getting executed, and instance block and constructor of B also getting executed. But they are linked. Even though they are created separately, they are linked. In the JVM it happens like that. Clear? But criteria for overriding continues. Object. You created B object, it will execute from subclass. This concept takes some time for you to understand. Don't go there now. Okay. Slowly you understand that later. Clear? Okay. Any other questions? If you are not followed this point, leave it. Concentrate on overriding. You shift our focus onto what? Overriding itself. Do not bother about that. Shall I clear this now? And this is very, very important, what I showed you now. A is equal to new A dot M1. Remember, the method of fun is executed from subclass. Remember that. A is equal to new B. Do not forget this. This is very, very, very crucial now. Which one? A is equal to new B if you create. This point is very, very important. A dot M1. Yes, M1 will be executed, but M1 will call fun of subclass. This is how it will work finally. Practically, you will be writing code like this. Practically, I am telling you. In real situations, we do coding like this. Yeah, see, the same thing now, there is no change. Only we should, I'll first work with only A class, then we'll come to B class. First, I'll finish it off. Class, what name I'll give? Invoking overridden method in superclass. Clear? Invoking overridden method in superclass. Yes. First I'll show you with one class. We'll remove this. See this. There's one class. Now first understand this concept. A is equal to new A. Done. A dot M1. This you know, it's very simple. A dot fun. So you're accessing fun outside the class. M1 also outside the class means the members of A are accessed in demo class. There's no issue here. Fine. Only one thing what I'm doing is I'll call fun inside the same class. Understood? Inside the same class. Till now I was accessing fun in another class. Now I'm calling fun in same class. No issue. Correct. Everything is correct. So here you don't have difficulty. We have seen this earlier. No problem with this. So next let's come to B class now. Class B extends A. Clear? So now time being I'll remove this fun. Time being I'll remove that. Okay. Now see this. Now we'll work with B object first. You know, here also not big thing. You understanding everything here. No issue. The subclass members we are accessing it in another class. This also is fine for you. The overridden method of B gets executed. This also is clear for you. Yes. But now this overridden method I'll call it in M2. Following now? So just focus on M2 method. I'll remove these two methods now. I'm only concentrating on M2 method. Just see this now. So this M2 will call fun from subclass because you have created an object of subclass. See this. B fun. Are you clear? Yes. The same thing now. What I do, I am creating B object, but I will call fun from where? Superclass. Understood? Now see this. BB is equal to new B. Now I'll comment M2 you understood. There's no issue with this. But I'll call M1 method. Which I am calling M1 method. So see this. We are calling M1, but fun is executed from where? Subclass. Fun is executed from subclass. Very clear it is. Criteria, M1 is in superclass. Okay, but it is executing from subclass. But the same, I'll call M1 with A object. See this one. It will call from where? Superclass. Getting it? Same M1 will call from where? See, there are two output. One inside A M1, A fun. Why two output? One we are working with A object, other one is working with B object. See the difference. Same M1 is calling in B from subclass. Clear? Fine. Then this is understood now. Are you clear with this? This is the point what I wanted to tell you. And more. If you want, you can try with this. Here, see now. A is equal to, now let's come back to this. We'll comment all this now. See, A is equal to new A. M1 is executed from where? You know it very well now. It is executing from same class. Criteria for now overriding is not there actually. But if I say A is equal to new B, now M1 will execute from again subclass. Same thing, again B object only is getting created, but we are invoking M1 now. M1 will call from same thing, what you saw here only. BB is equal to new B, B dot M1 from where it was calling? Subclass. I told you, variable will not decide which method will execute. Decision is taken by JVM, which one to execute. Variable only decides what member can be accessed. Variable only decides what member can be accessed. JVM decides which one to be accessed. So see this now. Both the cases it will print what? AM1, B fun. Understood? Okay, B dot M1, M1 is executed from A, but fun is executed from B. Correct now? Clear this? So see, M1 is there in superclass, but fun is executed from subclass. Clear? So criteria for overriding is object. It will never depend on the variable. What members can be accessed from the object depends on the type of variable. Which member gets accessed depends on the type of object you create. And you can access it from anywhere. Are you clear? Okay. So work with all this. Okay. And get clear all the concepts. So this is one thing about overriding. Very important thing. Okay. Now, I was telling you, when you create the subclass object, superclass will be different, subclass will be different. No? I'll give you one more explanation for that. See this. This example will give a demo for that. Subclass object demo. This is how the subclass object gets created. That's what I'm showing you now. See, A is having one static block. A will have one instance block. Yeah, we are adding more members into subclass today. Okay, we'll add. You can add. Till now I have not shown you this. Means I had shown you once. Just I am revising again back to you. Which one? You can, till now we saw how to write variables in subclass, constructors in subclass, methods in subclass. If you want, you can write blocks also. That I'll show you now. Clear? So, and at the same time, parallel I'm showing how the subclass object gets created. Clear? So I can add, see if superclass is having all these members, I can have one constructor also. What constructor I'll have? Okay, we'll have one constructor and one method. These are only the possible members now what a class can have. So this is a constructor. Inside here. So valid. A class is valid. So what are the members of class A? Static block, instance block, constructor, M1, all this you know. So class B will extend A now. Same story will be there now. So when you write a subclass also can have all the members. So class B extends A. Static block inside B static. Inside B instance. inside, you see this is constructor. This I'll change it to M2, a different method inside BM2. Finished. So now subclass can have all these members. Now see this. First we'll remove all this. Yeah, see this now. I will say AA is equal to new A. You know about A object. Understood? And I can call A dot M1 method. All this is okay, normal for you? You know how it works? A static, A instance, A constructor, M1. Clear? Okay. Now, we'll comment this. BB is equal to new B, B dot M1. So check out now. First A static, B static, A instance, A constructor, B instance, B constructor, M2. I'm creating only B object. A static, B static. A instance, A constructor, B instance, B constructor. So this is how it gets executed. But actually what's happening here is, when the subclass object is getting created, see first A class is loaded into the JVM. Then B class is loaded into the JVM. It's very difficult to draw and tell you all this, but just understand. And then the objects start getting created. Means the object of A gets created, then the subclass object gets created. So here what happens, this keyword will be referring to, if I use this here, it will be referring to B class. If I use here this keyword, it will be referring to A class. And one more super keyword will be referring to super class. They are different, but still they are linked. In the stack, heap and all, they are arranged in their own format. Understood? It's very difficult to try and explain that, but we have to virtually assume like it is working like that. Understood? So this is how it happens. Are you clear? They are actually detached. Don't think, because in the JVM what's happening, variables are kept in one place, methods are kept in one place and all. So that's how it's arranging. Blocks are kept, constructors are kept. So it's very difficult to draw virtually. Understood? So they are different, but they are still linked. This was what I was telling him before. Just I started typing the program. Clear? And now one more thing we'll say. If I say AA is equal to new A now, what happens? Class A is already loaded. Okay, here it is loaded, object is created. Now this time BB is equal to new B, only B class gets loaded. This also you should know. So earlier when you are creating the B object, A static and B static simultaneously was happening, but now it's not happening. A static, A instance, A constructor. Now only which one is happening? Okay. B static. So A instance, A static, A instance, A constructor. M1 I have not called, I think. A dot M1. Yeah. So that will help you to clarify it. So A object gets created, A static, A instance, A constructor, M1. After A object is created, I am trying to create B. But here A static is not executed. Why? A class was already loaded into the JVM. So B static, A instance, A constructor, B instance, B constructor. This is how it is. Clear? Clear this? So check out A M1. Okay, I'm calling B dot M1. M1 is in superclass. It will execute from superclass. That's it. Clear? Story will continue. C class extends A. Again, same story. So again, C extends A. It will be different only. Again, there will be this keyword referring to this object. Super keyword referring to. So super will always check in immediate superclass. If not, preference is given to class A. This is how it works. Understood? This is how it goes on. Clear? Any questions? Clear, no? Okay. But do not bother too much about that actually. Because in programming we don't bother too much about that. You start getting the output. Because internally how it works, we are not concerned. But doubts, yes, we can clear like this. Clear? But botheration, no, don't do. Clear? Okay, that's it then. About which one? Subclass object demo, how it gets created. You can try with class C. Understood? I have shown you class A, B, C, no long back. You can try with that. Should I clear this now? Okay. Now, see, we know how to design subclasses now, but still we have not learned how to work with subclasses. Still that is pending now. We know how to write subclasses. Means you can write When you write a subclass, you can add blocks, you can write constructors, you can overload constructors. Okay, means okay, when you write a subclass, you can write blocks, static or instance. When you write a subclass, you can write constructors, you can overload. When you write a method, you can overload, override, or write a new method. All this you can do. Okay, so you know how to write subclasses now. Still we are not studied how to use subclasses properly. That's what I was showing you, creating subclass object, how it works. So we going to learn now how to use subclass objects. So when you are using subclass object, see, how do you use subclass object? Clearly get the flow now. How do you use subclass object? Now my focus is shifting on to what? Designing subclass is over now. My focus is shifting on to how to use a subclass object. Understood? How to use a subclass object. I'm shifting my focus to that now. Okay, see this. PSVM. So now supposingly if there is A class and B class, if this is the hierarchy, I can create the B object. So when I create the B object, highly valid code, now I have an option to work with that object either with superclass variable or with subclass variable. So we should know how to work with subclass object now. Both are correct, but this is only tight coupling. Only thing is, this is tight coupling. Tight coupling means, if you want to change the logic, it is very difficult. You have to, means if I want to work with C, D, and all, it will be very difficult. Clear? Tight coupling. This tight coupling. But here if I go like this, it will be a loose coupling. So which one you decide. So there is advantage in both and disadvantage in both. Advantage here is loose coupling, but disadvantage is we can't access subclass member. Yesterday we wrote this. Okay, when I do this, advantage is I can access all the members, but it becomes tight coupling. Both are optional. We can work like this. Are you clear? Okay, from here it builds now. More it builds. Understood? We are going to see now how to work with subclass objects. Shall I clear this now? Okay, see this. Class put the heading as typecasting reference variables. So you know we have done typecasting now. We are moving to the very important subject now. Most important subject of Java. Okay. So you know we have typecasted which one? Primitive types. You can typecast even your user-defined data types. You can typecast even your any data type can be typecasted. Primitive also, user-defined also. You know why we typecast primitive types. Go and check out. But today we'll see why do you typecast user-defined types. Understood? So this is also possible in Java. Very important subject. Very important subject. Many times we go on to do typecasting. Many times. Yeah. So let's see the reasons. Very simple. Say this first. You can write this down, or I think I'll tell you a few points. Yeah. Now see, as I was telling you just now, I'll show you the example itself. I was telling you something. What I was telling you? A is equal to new B. When I create an object like this, you will have a problem. What is the problem? You can't work with the subclass members, but sometimes it becomes a requirement. You want to work with the subclass members. So when you want to work, see here what has happened. 1 second. So when you want to work with subclass members, it is not possible here. I'll write with code and show you. In fact, you know you cannot work with the subclass member here. So, yeah. 1 second. 1 second. Yeah, you know you want to work with the subclass member. So when you create the B object, problem is you are referring it with A. That's the problem. So B object will be created. So these are the members of A, these are the members of B. I have not written any code here, don't worry, we'll write it. So it is referring now. Problem is we can access only superclass members. But if I want to access, see this, even BB, I can write B is equal to A, no? Now in this condition it should be possible, no? Earlier what was happening? You are doing A is equal to new A. Understood? Earlier you are telling A is equal to new A. So when you say A is, okay, let us write off the members now, it will be more clear otherwise. Int X, int Y, you can have your constructor. Look at the two classes now. There are two classes. You know the members now. Very clearly you know the members. Okay. So when I created the A is equal to new A, what happens? Only A object is created. Yes or no? So when you create A is equal to new A, first I start off with A, then we'll come to this. A is equal to new A. Okay. So an object of A gets created. You know the flow of constructors. It will have the method, M1 method. So this is A object. Clear now? You know what are the members of A. So when you create it, it can, that object you are referring it with which variable now? A variable of type A. Yes? But I cannot give the address or reference of this A object to B variable. Yes or no? Is it possible? Not possible. I cannot do this. This is wrong. Why? Because if B refers to this, where are the subclass members is the question. So I told you very clearly, a subclass variable cannot refer to superclass object. The rule continues. Clearly understand the statement. Subclass variable, reference variable cannot refer to superclass object. Means, still more clearly meaning, you are trying to give the reference value of superclass object to, you are trying to give the reference value of superclass object to subclass reference variable. Not possible. Here it is not possible. Clear? Okay, let's take another condition now. See the same thing. This is case number 1. This is case number 1. Clear? We'll see the case number 2 now. Case number 2 goes like this. A is equal to new B. Sorry, we have to spend some values in the constructor because constructor is there. Okay, that is okay, no problem. But just understand the object. A is equal to new B. Which object I am creating now? B object. See the case number 2 now. This is case number 1. Now the case number 2. So B object is created. What are the members of B now? Raji, mark it. A is equal to new B. So now which object is getting created? B object. What are the members of B? X, Y. Constructor is there. Same thing. What you have written, same code comes into existence. This dot X is equal to X. This dot Y is equal to Y. Then you got M1 method. All this story okay. But the extra member what you are having is Z now because you have created B object. B, int X, int Y, int Z. Super of X, Y. This dot Z is equal to Z. Void M2. So this is B object. Sorry, but referred by which one? Referred by which variable? Superclass variable. Perfect. So here now new B means subclass of construct. See, first focus on new B, then you see A. New B means first what happens? First what happens? Memory is allocated. New will allocate memory. Then which happens? What happens? The constructor of B gets executed. How does the constructor of B executes? New will allocate this complete memory. Then the constructor of B is executed. 5, 6, 7 are sent as arguments to X, Y, Z. 5, 6, 7 are sent as argument to XYZ. XYZ will means what it will do, you are sending the values to superclass. X and Y of superclass gets initialized to 5 and 6, Z gets initialized to 7. The object is ready. The reference of that object you gave it to A. Perfect, no? Superclass variable can refer to subclass object. Perfect. Now you can work with what? A dot X, A dot Y. You can work with all this. SOP, SOP. You can call A dot M1. But can I work with subclass members? Can I work with subclass members? No, these are correct. Understood? But I want to work. My requirement is that now. I've created. But now I want to work. But now you want to make work means don't tell I'll create BB is equal to new B. Understood? But I want to particularly work with this subclass object only. You can tell no. I'll write what? BB is equal to new B. One more object I'll create. BB is equal to new B. Again 5, 6, 7. Again you have to create one more B object. This is another story. But I don't want to work with another object. My requirement is what? I want to work with existing object itself. So this I don't want now. And I want to access the subclass members. I want to access the subclass members. Understood now? This will create another object. So this is ruled out now. So what to do? So I can declare, see this now. B, I am declaring a variable. This time B is equal to A should be valid now. Why? Now A is referring to subclass object. Previous condition it was referring to superclass object. In the first case it is referring to superclass object, but this time A is referring to subclass object. It is referring to subclass object. Got the point now? Okay. So now it should do this. B should be, means you should be able to give the reference of this object to B variable, but it will not compile, because compiler goes for what? Error. But it should be possible. Okay. But what you can do is, here you can do casting. Now it will work. Now it can work. How will you do? Instead of writing the code like this, you say B is equal to B of A. You know typecasting now? A typecast it to B, then give it to B. End of the day what will happen now? A will be means typecasted to B, and see the syntax. B is equal to B of, sorry, A will be typecasted to B and given to B now. Now you can access. Now what will happen is B will refer to this object. Both the variables are referring to the same object. Both the variables are referring to the same object. A also is referring to B object only. B also is referring to B object. You print the address and check. SOP A, SOP B. Both will be having the same reference value. Okay. But now what I'll do? I can access the member. How? With B I can access superclass members also and subclass member. With A I can access only superclass member. So here one thing what you have to understand is a superclass variable can be typecasted to, there's one condition, but simply say, if I say AA is equal to new A, sorry here, AA is equal to new A, correct, this one. Here if I try to typecast, it will not work. Here if I try to typecast, it will not work. Why it will not work? Because it's of type superclass. But here it will definitely typecast. So a superclass reference variable can be typecasted or casted into subclass type only and if it refers to subclass object. Condition is that. The clear condition is there. A subclass variable can be typecasted to, what is that? A superclass reference variable can be typecasted to subclass type only and if the superclass variable refers to subclass object. This is possible. Understood? And why do you do typecasting of user defined data type? Only one reason, there is no other reason. Just to access subclass members, nothing else. The only one reason why we typecasting is to access subclass members, no other reason. So whenever you want to access subclass member, typecast means sometimes you'll write the code like this. What? To decouple you'll do off. Understood? And later on you want to work with subclass object members. That time you can typecast. Understood? We'll be seeing all this practically, but just get all these points now. So we are learning how to work with what still? Subclass object. We are learning now. You know how to write a class. You don't have any doubts about writing a subclass. But now we are focusing on how to work with subclass data type. Now we have started practically. Understood now? We are learning how to work with subclass data type. So you can typecast. This is possible. Are you clear with this? And only one reason why you'll be doing typecasting is to access subclass member. With B you access now. You can't access it with A. Both the members are referring to the same object. But I can work now. B dot Z valid. With B you can access all members. Not only Z and which one? M2. You can call the method. You can access even B dot X, B dot Y. Plus, there is no place. But are you getting it now? B dot X, B dot Y. At the same time you can print B dot M2 also. All are possible. You can access all the 5 members. X, Y, Z, M1 and M2. All 5 with B. But with A only superclass members. And you know the condition now. What members can be accessed from the object depends on the type of variable. I am coming back to the same old point only. What members can be accessed from the object depends on the type of variable. But if methods are overridden, it will be depending on object. You have an overridden method here. You call it from A dot. Supposingly I override M1. Supposingly I override it. You call A dot M1 or B dot M1. From where it will execute? Subclass only. Overriding rule continues. And supposingly I override. I am telling you. Are you following now? If I override M1, what will happen now? A is also referring to the same object. B is also referring to the same object. Understood? A dot M1 this time it will execute from subclass. Now you can access. Understood? But it will execute from subclass. Understood? Remember the point, man. What members can be accessed depends on the type of variable. Which one gets accessed depends on the type of object. All rules continue. Only I showed you typecasting. Okay, only I showed you typecasting. And here in Java, see this. Again, I'll explain you in very simple style typecasting here. See, AA is equal to new B. Understood? Supposingly I have one B variable here. Supposingly, if I say, see this, 1 second, let us come back here now. AA is equal to new, sorry. See the two conditions now. BB is equal to new B. I'll have one variable. A is equal to B is valid. Yes or no? Yes or no? Why it is valid? Superclass variable is referring to subclass object. Okay. Here also it is casting only. Here also it is casting only. Here what is happening? You are trying to give subclass to superclass. It is correct. Okay. This is also casting only. But only thing you see, we are trying to give what? Subclass to superclass. Means we are trying to give. Now see, in casting you know primitives I taught. You can always give smaller value to bigger data type. You can always give what? Smaller value to bigger. I'm comparing this with primitive now, so that you understand clearly. Okay. In typecasting of primitive types, we saw that you can always give a smaller value to bigger data type. Means byte A is equal to 1. Byte A is equal to 1. Very easily you can give it to int now. Int I is equal to A. Valid now. So smaller value can be given to bigger data type. Same thing is happening here. Is implicit. Same thing is happening. Understood? Okay, you are giving a smaller value to bigger data type. Now you might question, B is subclass. It is big. It is having more members. Understood? You might question now, who is big now? A or B? Who is big? Means who is the great here? A class or B class? Confused. Do not get confused. Go to the father and son relation. Who is great? Father. Father is always big. Understood? Son can have extra qualities, but still father himself is great. Understood? No? Father himself is great. So that is why what happens, see here you are trying to give, it can have extra members. We are not bothered about that. Superclass is only big. Subclass is only small. So that is why here what happens, you are trying to give smaller value to bigger data type. Perfect. Perfect. Okay, and this happens implicitly. This happens implicitly. Okay, and this is also known as upcasting. Technically we call it as upcasting. Upcasting means we are moving up the hierarchy. We are moving up the hierarchy. Upcasting it's called. Technically they call it like that. For primitives they don't have these words. This upcasting and downcasting comes only for user defined types. Okay. Here what's happening? See now, B is equal to B of A. What are we trying to do? We are trying to give bigger data type to smaller one. Yes or no? We are trying to give bigger data type to smaller one. A, that is big, superclass. We are giving to smaller one. Correct. You can do it, but only when it is But you have to do it explicitly. You have to do it explicitly, and you can do this under only one condition. What is the condition? Superclass variable should be referring to subclass object. Only under that condition you can do explicit typecasting. Okay. So here this is called as explicit casting. Which one? This line. What I have written here. Okay, I'll write it here now. See the other condition. A is equal to new B. Okay. Then B. Now see, B is equal to A error. Why? You have to do casting here. Okay, but you have to do it explicitly. B is equal to B of A. Same code. There is no change. A will typecast to B and give it to B. So this itself is called as what? Explicit casting or downcasting. Downcasting. Upcasting and downcasting they tell. So you are casting it to down the hierarchy. In the inheritance tree, you are casting it down. Means A is on top, B is on bottom. So you are casting it down. From A you are casting it what? To B. So that's why it's called as downcasting. Upcasting means casting up the hierarchy. Downcasting means casting down the hierarchy. Upcasting is implicit. Downcasting is explicit. That's it. Now why do you do downcasting? Simple. To access subclass members. Now no other reason. I might have told a big story here. End of the reason that it's very simple. We want to access member from the object. Understood? End of the day we are doing it only to access the members. Nothing more else. Are you clear with this? Upcasting and downcasting. Upcasting implicit. Why? Smaller value to bigger data type. Okay, here explicit. Why? Bigger value to smaller data type. Yes, you can do this. But rule is there. A should be referring to B object, means subclass object. AA is equal to new A? Not possible. AA is equal to new A? Not possible. Because A is referring to superclass object. Clear this? So only under this condition, casting can be done. This is so important concept. We'll start applying this practically. So practice lot. Understood? Because I'm going to introduce the next big keyword. One more keyword is there, instance of operator. Okay, if you want to really understand that, work hard on this. Instance of, I have to teach you that. So you should be very good in what? Casting like this. Clear? Shall I clear all this now? We'll type and see the program. Any questions you are having now? Simple it is. A superclass variable can be typecasted to subclass type only and if refers to superclass object. Very simple. And it is done for accessing subclass members. That's it. Process is known as downcasting. Clear? Shall I clear? Okay, see this class A will have what? Members, index, comma, y you can have one constructor, Here we have a class here. If you want, see this, what I'll do is I'll write the subclass now. So class B will extend A now. And you'll have an extra variable called as Z. And you have a constructor here. Int x5, it will get 3 parameters because you have to initialize 3 instance variables. And I will initialize the superclass variables by sending them as arguments to the superclass constructor. And finally we'll tell this dot z is equal to z. Z is initialized. You know how to write the subclass. And finally you'll have m2 method inside B m2. Done now? Class B is extending A. So now let's see this. See A is equal to new A. I'll create the object 1 comma 2. I'm creating an object of A. Understood? So once the A object is created, I can work with A dot value of x in A. Similarly, you can put all the values. A dot x, I can access only 2 values. A dot x, A dot y. And also I can call M1 method. A dot M1. First work with this normal class. You are comfortable, then continue. It will execute, no issues. X is 1, Y is 2, M1 you have invoked. I will declare a variable of type A1. One more variable of type what? Superclass. Now A1 is equal to A is valid. Yes or no? I can give the address of this object to a variable of type, same type, superclass type. And you can work, same thing will go on. Same thing will go on. Now what I'll say, A1 dot x, both are referring to the same address. And if you want, you can print one more. Value of A is value of A1 is. Value of A is plus A. Similarly, we can say value of A1 is plus A1. Go very slow with the basics. Don't jump directly into the example. See, A address and A1 address both are same or not? This is A address, this is A1 address. Both are same. Clear? Fine. So now, the same I'll try to do it with which one? B. This will comment down. The same we'll try to do it with what? B now. Let's see. B is equal to null. Understood? B is equal to A. Not possible. And you get compilation error. Check this. It's compiler error. How can you give a bigger value to smaller data type? So a compiler only will give the error to you. It's not possible, it says. Compiler error now. See this. We cannot give a bigger data type to smaller one. Yes or no? Yes. So I understood all this now. So then next, what all we'll say? Yes, but it's possible with the process of what? Typecasting. So you can do this. It will compile this time. So yeah, you can compile. Okay, it will compile this time because your syntax is correct. Your syntax is correct, it will definitely compile. This is the correct syntax. You are trying to typecast A to B. Compiles. But during runtime, if you try to access B dot, which method? Okay, M1 or M2, anything you try to access. See here. Anything. Even I'll try to access one second. Forget. X only I'll access, which is there in superclass. B dot X. Let's see this. So see here it compiled. Remember, here it see here it will not come. In this line it is error. Which error? Compilation error. First I'll show you that. This is compilation error now. Why? You are giving bigger value to smaller data type. So now I'll comment this. I'll open this. It is compiling. Why? Syntax is correct. You are writing the code of typecasting. Correct, it will compile. Okay, but when I open this one, see what happens. I'm trying to print the, sorry, SOP I have to do, no? I'm calling it as a method. Sorry. Value of y in B is just accessing b dot y and nothing else. See what happens. It compiles. We get one problem there. Class cast exception. It will compile, but you can't work with B. You can't work with B. Okay, when will you get class cast exception now? When you try to typecast a superclass variable to subclass type, and superclass is referring to superclass itself. It cannot be casted like this. Understood? So you will get this class cast. Anyway, that is a big thing now. Just we are seeing it in a small way. Okay, this is done now. So fine. Now what I will do is, see now, A is equal to new B. One small change I will do. Now same code will take. B is equal to A is what? Error as it is. Understood? Same. Only change I have done is what? B object I have created now. Okay. So I will comment this. I am typecasting what? Correct. It will compile this time also. But now you can access your subclass member. See that? You can access your subclass member. Understood? Clear this? This is what is typecasting. And you typecast it only for one reason, to access subclass member. Yeah? Okay. One more thing. See. More things. Yeah, this is called as what now? Now I'll show you. This is called as explicit casting. You are casting it explicitly, or also known as downcasting. Both are correct. Downcasting you have to always do it explicitly. Are you clear with the downcasting? This is an example for what? Downcasting or explicit casting. I'll show you now which one, implicit casting or upcasting. Now let's see that. Clear with upcasting? Sorry, downcasting. Now let's see an example. You know already upcasting. You already know it. See this. B is equal to new B. I'll create an object of B now. U value is like 5, 6, 7. B object is created. A. Exactly. Then we are creating an object of subclass, and you will say A is equal to B. What is this? Implicit or upcasting. This is an example for downcasting. This is an example for upcasting. Upcasting or implicit casting. Done? Implicit now. And now I can work with what? All the members. See here. With B you can work with all members. See, A is equal to B. I'll comment all this now. With B you could have worked with all the members. Yes or no? But with A I can work with only superclass members. This is implicit. You already know this. You try to access that, you will give error. Correct now? Are you clear? So we'll go to downcasting only. Some more I'll show you there. Clear? Implicit casting you know. This is upcasting. Implicit casting is nothing but up. And one more line. See here. If you want, you can do it explicitly. A is equal to A. But you don't have to do it. It's valid. I'll comment this. Valid it is. If you want, you can write it explicitly, but it will support your implicitly. See here, I am writing it explicitly now. Understood? Explicit casting. It is explicit but not required. Explicit but not required. Are you clear? Oh yes, let's go back to implicit itself now. Sorry. Let's go to sorry. Yeah, we are doing explicit but not required. We are doing it explicitly but not required. It happens implicitly. Now you understand? Don't get confused there. I have written implicit also, explicit also. But don't get confused. Implicitly it's happening. If you want, you can do it explicitly. Understood? Yes. We'll come back to downcasting now. We'll check this. See, A is equal to new B. Yes. We have created the B object and it is referred with A. Now as accessing, here the problem is what? We can access only superclass members. But if I want to access subclass members, it's not possible. That's why I'll declare a variable of type B, subclass type, and then I'll typecast A to B. With B I can access what? All the members. With B I can access all the members. Check. But before that, we'll print value of B actually. We'll print only, means both will be referring to the same address. That is what you see now. Here A and B both will be referring to the same address. Value of B is plus B. You see this first. Then we'll come to accessing the members. We'll comment all. So I commented everything. Just I created the A object. I'm declaring a variable, typecasting and giving the value to B. Let's see the address, value of A and B. Both are referring, sorry. B is already defined. Okay, we have to comment this now. Can you focus on that? See this? Both are having the same address. Value of A is also same, means both are referring to the same object. Yes? Now see, we'll try accessing the members. You can access any member. So with A you can access all your members, with B you can access what? All the members. So that's the only reason why you typecast, nothing else. Value of, go on typing now. Value of X in B is B dot X, B dot Y. Value of Z in not only X, Y, Z, you can access even what? B dot M1 plus you can call B dot M2. All this is correct. All the members you can access. Happily it executes. That's the only reason you typecast. Nothing else. Understood? But if I override, now very interesting. Which one I'll override? M1 I'll change. Inside B, overridden. That's why overriding becomes a very big subject. Overriding is easy. But which overridden method gets executed under what condition, that is very important. You'll override it. But remember, again, I'm telling you, criteria for overriding is object. That is also very simple. Understood? So now inside B overriding. So let's see now. A dot M1, it will execute from where? That is going to continue, there is no change. B dot M1 it will execute from, okay, M2 you cannot call now. You create A object or here we have created B object. We have created B object and you are referring it with A variable. And you are referring it with B variable. Refer it from any variable, it is not bothered. It will always execute from subclass only. Criteria for overriding is same. I have called twice A dot M1. This is the output of what? A dot M1. So it's executing what? Inside B overriding. I am calling B dot M1. It's executing what? B overriding. You typecast, but whatever you do, okay, but it will be executing from subclass. But you understood why you do typecasting? That's all. Sometimes you will superclass variable refer to subclass object and you want to access subclass members, then you typecast superclass variable to subclass type. Nothing else. It's not a big thing. And all rules continue. Once you typecast, what members you can access from the object depends on the type of variable. Means, see this. See this clearly now? You got your code. Box B is equal to new shipment, I'll tell now. 5, 6, 7, 8, 9. I created which object? Shipment. So shipment object will be created now. Full. You know the story now. W, H, D. You write all the members. I'm just writing few members. Volume. Assuming that you're having volume method extra. Constructors I'm not writing, you know the flow. Volume method, M1 method. Now I'll have M and I'll have M2 method. Then I'll have cost. Then I'll have M3 method. So which object has got created now? Shipment. But it is referred by which one? B, a variable at top box. I can typecast. To access B typecast. How will you typecast? B can be typecasted to box weight. Possible. You can typecast B to box weight. Now BW will refer to this. If BW refers to this, what you can access? What members you can access depends on what? Type of variable. Means I can access WHND, volume, M1, M, M2. All I can access with BW. But if I want to access all the members in the object, shipment S is equal to shipment of, you can write it in a single line. You don't have to declare and then do all that. As simple as this. So now shipment can access all them. All are referring to the same object. Today try this. So what members, that becomes very clear now. What members can be accessed from your object depends on the type of reference variable. Which one gets accessed depends on the type of object. So this is Java. Understood? Any questions? Okay. We can write some notes on what? Typecasting. Shall I clear this? So it's very clear now. You can typecast user-defined data types. Yeah. Yeah. The heading is typecasting reference variables or user-defined data types. Typecasting reference variables or user-defined data. See, a superclass reference variable can refer to same point. You know that. I'm not telling no. A superclass reference variable can refer to subclass object, but what members can be accessed from the subclass object depends on the type of superclass reference variable. Yes or no? Yes. Next point now. But if you want to access the subclass member, then the superclass reference variable can be casted to subclass. Correct? Yes. But you can't typecast what? All superclass to subclass. There is a condition. A superclass reference variable can be casted to subclass type only and if the superclass variable is referring to subclass object. This is a condition. Next, this is done only for one main reason, that is to access the subclass members and nothing else. Next point. This process is also known as downcasting, means casting down the inheritance tree. Downcasting means casting down the inheritance tree. Means from A you will cast it to B. Down you are going. Understood? Downcasting has to be done explicitly. Understood? Upcasting means casting up the inheritance tree. This happens implicitly. BB, see, a good example for these two is, you know now, upcasting, downcasting, understood now? That's it. Here, this downcasting means A is equal to new B. You'll cast this down now. You're casting it down. From A you're casting it to down. This is downcasting. Understood? Then one more for upcasting. A is equal to new, sorry sir, B is equal to new B, A is equal to B. This is upcasting. You are casting B to A, up you are going. Understood? That is implicit. This is explicit, that is implicit. Be clear with all these concepts because we are going to write applications fast now. Very shortly your Java will be over now. Hardly have to complete what? Abstract class, interface, packages, exception handling. That's it, Java over. Understood? Nothing else is there, and only libraries later on. So there when we start working with built-in types, you should know what all you are doing. Clear? Hardly 3-4 topics pending now. Any questions? Yeah? Okay, you can write it. Then the next topic is instance of operator. Just I'll start it. Introduction I'll give. Next class we'll see it in depth. But to understand instance of operator, it should be perfect. Perfect means perfect here. No chance of any loophole here. Understood? No margin, even allowance is not here. It should be very perfect in all this. Just this is introduction. And instance of, it's an operator. You can go and see the list. Notes I'll give for this in the next class. It's a keyword, remember, first of all. It's a keyword, so no space in between both of them. Keywords do not have space. Understood? And write I small only. Don't write instance of caps, because it's a keyword. Okay, let's see this one. Same classes you take, A and B. Which one? X, Y, Z. Same thing you take. I'll just write the members X, Y, M1. You know how to construct and all same. Just to make you understand, I'm writing it again. Class B extends A. Take this example only. Z, M2 method. Constructor and all will be there. Leave that. Take the same example. PSVM. Okay. See this? I'll say A is equal to new B. You know 5, 6, 7 object gets created B object. Before typecasting, we apply one small logic. Everything will work, you have seen it now. Only one thing what we do is, we check like this. If A instance of B, then you have to typecast. A will be typecasted to B. That's all, one extra line you will write. That you'll understand next examples why we do this. Just get the grip on how you use instance of operator. Means it's always recommended and advised that before you typecast, you check and then typecast. Typecasting will work. Okay, but why they are recommending and to do that is, you'll understand in the later classes. Next class. Understood? Everything is same now. If it is an instance of B, then you typecast. Okay. Yeah, otherwise for this one I'll change the program little. I'll change it, I'll make it understand for you why we do that. I'll use it little to one extent. Class A, M1, now this is the example. You take down this example for instance. I'll give a better one. Void M1. First work with two classes. A is equal to new B. What will you do? If A instance of B, what will you do? You will typecast and call what? B dot M1 also you can call, B dot M2. Both the methods you can call. Because with A you can call only what? M1. Understood? Fine. Now see, we are creating one hierarchical inheritance. Hierarchical. B, C, D. All are hierarchical now. Be careful with that. Class C extends which one? A. Be careful with this. Void M3. Understood? So now see, now if I change it off here, no need of any constructor here. Okay, A is equal to new B, this will work perfectly, it will work. But tomorrow if I change it to C, what will happen? This code will go wrong. Understood? It's not, means it will not execute this. It will not execute this because it's not an object of C. So it will skip, you will not get any error. But blindly if I had typecasted A to B, what would have happened? See first, if you say, look at this code. A is equal to new B. Directly if I typecast it will work. And I can call what? B dot M1 also I can call. B dot M2 I can call. Yeah? But by chance if I change this to C, this code will go wrong. You can this leave this part now. Leave this part, you forget. This code will go wrong. Understood? Why it will go wrong? Because you are typecasting A to B, but it's an object of type C. That's why it goes wrong, and all this code will go wrong. That's why before you cast, you check like this. But otherwise, see, if I want to do that, I could have done like this. See, if I'll write now like this, conditions. If instance of B typecast, else if, again go on, A instance of C, what will you do? Typecast it to C. Valid now? C dot M1, C dot M3. So that's why before we typecast now, we check and typecast. Again you might have one more D class. Again you'll write one more condition. Else if A instance of D. Continue the program. You'll typecast D is equal to D of A. And you can call. Example, if there is a class D extending A and you are having on M4 method. Just work with this and come. Next class I will be taking in detail about this. Inside M4, DM4 or something. So you can call D dot M1 also, you can call D dot M4 also you can call. See, problem is you can change it off here anytime. You'll be decoupling. Understood? Sometimes you want B object, sometimes you want C object, sometimes you want D object. So whichever one you want, you'll change it off here. But now which object is created, that particular logic has to execute. Blindly you can't typecast. Blindly you can't typecast. Now you might be thinking, very well, I can clearly see B only I have created, I'll typecast it to B. Okay, this will, during programs you'll understand, this object will be dynamic. You will never know which object it is getting created here. Understood? You will never know. Now right now you can tell, I know very clearly B only is getting created, I'll typecast it to B. During programs you will never know which object will be created and your variable will be referring to which object. You will never know. That's why before we typecast, we write conditions like this. If it is an instance of B, typecast it to B. If it is an instance of C, typecast it to C and call C members. Okay, if it is a type of D, typecast it to D and call D members. Typecasting, everything is correct. But only before typecasting, check and typecast. So before typecasting, if you want to check, we use instance of operator. Clear? And now when you are using instance of operator, this is an operator. This is an operator. This is left hand side, this is right hand side. Remember, when you use instance of operator now, A instance of B. Now, understood, A instance of B, this should be compulsory subclass. And this should be compulsory superclass. So on the left hand side, you should have superclass variable. On the right hand side, you should have subclass. A instance of B. Remember this, only then it will work. Means, if you want to use instance of operator, these two classes should pass is a relation. B is A, or rather, animal is dog. Sorry, dog is animal. I'll be explaining with that example also. So only when the two classes pass is a relation, then only you can use the instance. Means if they are inherited. Other way of telling is they should be related. Only in they can be completely different. Here, I cannot say if A instance of box, error, because box is not at all related with A here. Compiler only will report error to you. A is not of type box only. The compiler knows the hierarchy. Okay, A is not related to box means it will not allow you to use which class here? Box class, hello class, it will not allow you. Understood? Compulsory they should be related. Only then it will work. So this more in depth, next class we'll see. Just understand that before you typecast, check and typecast, that's it. Clear this? This is the introduction. Next class will be going deeper into this. Clear? Okay, that's it. Notes for instance of next class I'll give.